All right. Cool. All right, you guys. So we're gonna cover, I think, like 5 topics this week. Let's look through them. Number properties. Okay, number properties. That's gonna be like kind of interesting. Imaginary and complex numbers. We're gonna cover translation, which is how to turn a word problem into an equation that you can use. We're gonna cover that. We'll cover a very little bit of matrices and a very little bit of vectors. Okay? That's what's on this section.
We didn't learn matrices at all.
I know. So here's the thing. In our district, the place that you should have learned matrices, because we don't really teach them in the standard pathway anymore, is if you had honors secondary math 1, right? When you guys switched to sec math 1, 2, 3, they took out pre-calculus, and they took the pre-calculus topics and divided it between sec math 1, sec math 2, sec math 3, honors. The honors topics for sec math 1 are matrices and vectors, I think. If you haven't learned it, it's not a big deal. I'll teach you everything you need to know today for the ACT, and I can teach you everything about matrices anytime. Okay? Same with vectors. It's pretty straightforward. I just need to introduce you to it. All right? Okay, so here we go. Let's talk about number properties. We kind of just are looking at the properties of odd and even integers, positive and negative, absolute value. What do you guys think? If x plus 1 is an odd integer, is 3x plus 2 odd or even?
Even.
I hear odd, I hear even question mark? Even? Okay, if x plus 1 is odd, what's x? Even. Does that part make sense? So I'm an even number. What's an even number times 3? Check that if you want, like do some examples. 3 times 4, 3 times 6. It's even. What's an even number plus 2? It's even. Okay. You can pick numbers though to kind of try to tell, right? We talked about absolute value last week. We're going to talk about it a little more here, but if n is a negative number, the absolute value of n is the opposite of n, or negative n. It's kind of a weird way to think of it, but basically, the absolute value of negative 3 is 3. Negative 3 is also 3. So putting an absolute value around a negative number is the same as multiplying by a negative. Okay, before we do these, I want you guys to go to this chart right here. All right?
Oh.
Okay, this is kind of cool. A lot of this is number theory, which you can really get into some cool like number theory stuff. These are sets of numbers, so you want to know what the different words mean. Okay? So we're going to start at the bottom. The smallest set of numbers that we deal with anyways are the natural numbers. How would you guys describe those numbers?
Positive integers.
Yeah, they're all the positive integers, okay? And when I used to teach this like from the beginning, I called these counting numbers. Sometimes they're called counting numbers. Because like when you're playing hide and seek and you go count, are you like 0, 1, 2, 3, 4? No, everybody just starts counting with 1, right? Or if my kid's not moving fast enough, I'm like, I'm going to count to 3. 1, 2, 3. Okay, those are your natural numbers, your counting numbers, right? Your next set of numbers is your whole numbers. And the whole numbers, the only difference is it adds 0. Okay? So whole numbers is all the positives, positive integers, plus 0. Okay? And then that makes it a whole number. So that's all the difference between those two is whether it includes 0 or not. Okay? And then my next set of numbers is integers. And you guys know that integers are positive or negative or 0, but they're like not fractions or decimals, right? I would say like whole numbers, but whole numbers specifically means positives and zeros. So they're positive, they could be negative, they could be 0. But the natural numbers are a subset of integers. You guys understand that? The whole numbers are a subset of integers. These are all subsets. You could look at it like this, or you could think of it as circles where they're contained within each other.
That's how I've always seen this
Like
diagram.
circles,
I like the rectangle though.
This is kind of interesting. I've always seen it more like complex and then like circles, I guess.
Yeah, that's how I've always seen it. This
Yeah.
is way.
I kind of like these because it shows you what you add to get to the next one, right? Okay, guys, rational. Now, well, if you think about the word rational, it has the word ratio in it. And ratio means it can be made into a fraction. Now, all integers are rational because guess what? Like, the number 7 is 7 over 1. So that's still rational. I can make it into a fraction. So any fractions are rational. Things that we can make into fractions also, guys, are repeating decimals.
That's the big one.
Yeah, so like 0.333 repeating, what fraction is that?
1/3.
1/3. Okay? So repeating decimals, and then also what's called terminating decimals. Guys, terminating means they end, right? So 0.76154 is a rational number because I can turn it into a fraction, right? What fraction can I turn that into?
76154 over
Yeah,
10.
76154 over 10 something. 100,000 or something?
No, wouldn't it be over?
1, 2,
Oh,
3,
you're
4,
right.
5
You're right.
zeros,
Yeah.
yeah. Okay?
Maybe.
So, repeating decimals, terminating decimals are rational numbers. These are rational numbers, okay? Then we move out to irrational numbers, and the only difference on irrational is irrational numbers are non-repeating, okay? And non-terminating. So non-repeating, and I'll just use the word, they don't stop. They go on forever and ever and ever. The most common irrational numbers we know are pi and e. Yeah, you're at level math. Pi and e are irrational. The other things that are irrational are square roots, okay? Unless it's a perfect square, every square root is irrational. So like the square root of 7 is irrational, the square root of 8 is irrational, but the square root of 9 isn't. All right? Then together, the irrationals and the rationals make up the reals all together. Okay? Now, irrationals don't contain the rationals and vice versa. Like these are irrational, these are rational, but together they all make real numbers. Real numbers is something I can put on my calculator. Something that when I graph it, I can see it. So like square root 3, I can put that on my calculator or whatever. Outside of that, we have the complex number system, which is what pretty much all math that we do is in the complex number system. But the complex number system contains the real numbers, and then it contains the imaginaries over here.
What would be outside of complex numbers?
Nothing that I know. But there are other sets of numbers. I had to take a class called abstract algebra, I think. I was really bad at that. All I can remember is there's like rings, fields, and groups. But I don't really remember any of it. So there you go. So nothing that I could tell you. Okay, complex number system consists of A plus BI, where A is the real part, I is the imaginary part. Okay? And so the reason that real numbers are also complex, so like for example, the number -3, it's a complex number because it's -3 plus 0i. We just take away all the, The imaginary numbers take away the real part, and then complex is putting them together. Okay? Does that make sense? Okay, so let's go now. So let's go back and look at this real quick. Circle the ones that you guys think are rational right here. Which of the following are rational? Remember, rational means I can make it into a fraction. This is on the page before. Circle them if you guys think they're rational.
Well, Mitchell, why you gotta put so many square roots in here?
Because that's how you tell, basically. And again, I'm sorry about the quality of the copies. Until I have time to retype everything, they just look like this.
Is
My
the
bad.
fifth also squared? Is the fifth one?
Yeah, that's squared. It's 1 plus root 2 squared.
It looks like a 1.
I know, I'm very sorry. That one should say 1 plus the square root of 2 squared. Okay? Okay, square root of 8 irrational, so is square root of a half. The square root of 4 is rational because it's
1
1
half
half.
times 1 half.
Yep, the square root of 2 squared is rational because it's 2. This is irrational because if I multiply it out, I'm still going to have square root 2's left over. This is irrational because that's square root of 2. This one's good because it's square root of 4. And then I have an ending decimal and I have a repeating decimal. So if you can look at a set of numbers and pick out the rational ones, that's good. Okay, looking at the next one, which ones are irrational on the next list? Which are irrational?
I thought we were doing this. That's just like a rational.
I have a shirt. I should find it. I don't know where it is. It's like these guys, and one of them's 5i, and the other one's square root of 2. And this guy's saying, "Hey, be rational." And this was like, "Get real." Get it? It's funny. It's like funny. Thank you. Okay. Get real. Be rational. It's a very funny shirt. All right. I also have a shirt that says. It says things just got real. It's like, good, right?
The magical t-shirt last year
Isn't it the
was
math
that
club
but
shirt?
math.
Yeah, it was very similar to that math club. Okay, that's irrational. Square root of 81 is fine because that's 9. That's 5 over 2. But because that's 5 over root 2, that's irrational. And then that one's fine because it's repeating decimal. Okay, so let's try some questions about sets of numbers. I feel like that one's easy-ish, maybe. I think that one's more medium. That one's medium, that one's hard. Okay? 4 questions. You guys got this? Alright, 4 questions. We'll go 3 minutes, because I don't think you'll need 4 minutes. 3 minutes to do this. Did you bring your duck with you today? Sorry about that. All right, guys, let's take a look real quick here. Number one, the answer is E. You guys see that?
What?
No, I'm just kidding, it's D.
Oh, thank heavens.
I knew what it was, but my reverse up-down dyslexia messed me up. No, I'm just kidding. I knew it was 2 over X.
I didn't catch the first
Sorry.
bit, the 0x.
Sorry. Okay. Now, one way. Someone tell me though. Yeah, that's my bad. Someone tell me how you did that.
Because if you're dividing by a fraction, it makes it bigger.
Okay, so you can kind of think through it, but pick a number. Most people are going to do this by choosing like 1/2, plugging it in and seeing which is the biggest. That's probably what most people will do it. You could, you can say, well, when I have a fraction, when I divide by a fraction, it makes it really huge. If you know what the graphs of these look like, that's one way to do it. That's the way my brain works, but that's just me, right? Okay?
You can make it real big by doing that.
Yeah, you can get, because what happens as we're approaching 0 of that? What does that approach? Infinity. So someone last year was like, you could do that with calculus. And I'm like, yeah, actually you can, right? Because as I approach 0, the graph of 2 over x actually looks like this. So for the numbers between 0 and 1, they just keep getting bigger and bigger and bigger. Whereas the other graphs, like square root x stays down here, like x squared between 0 and 1 is like right there. You know, they all stay kind of small. That's the only one that gets really big.
If it went bigger than 1, if our options were 0x to 2, would
Then
it
it's
be
different because it switches
Would the
around.
answer
Would
be
A be
B?
the second
Probably.
biggest?
Because it's squared.
It's hard to say. As you're going to infinity, that would probably be the second biggest. And then probably that, and then
Well, I mean, like, in the restrictions.
in that restriction, square 2x would be the biggest in that restriction. Okay. You guys, I think a lot of people saw this a little different than me. Are you guys just like plugging in numbers and see if it works? I did this a little bit differently. I actually went and solved it. I was like, well, I can solve that. If I add 2x to both sides, that's x.
Mitchell, why you gotta do it like that?
I don't know. I feel like that's the easiest way to do it.
That's going to be the most consistent way. The easiest way is to look at our options
Yeah.
and try and violate.
And try to go through it to counterexamples, yeah.
Yeah.
So I did that one, and I just said, oh, if x can be anything bigger than 1, are all whole, or sorry, less than 1, are all whole numbers less than 1? No. Are negative numbers less than 1? Yes.
Actually, a very consistent.
Are non-negative numbers less than 1? No, because non-negative means positive. That screwed me up earlier. Is it all integers are less than 1? No. And is the empty set less than 1? No.
So it is
But-
G. I just thought
yeah,
I
so
got
it's
rid of
G.
the negative.
Oh, dang.
Or if you guys just like kind of thought about it, that works too, or pick sets of numbers, that works.
Mitch, Delano got that right and I got it wrong.
Add a kid to line.
What
Oh.
the
Get
heck?
rid of the
All right.
negatives.
I like this question. So it says,
Why are you singing?
if x squared times y is less than 0, without even reading the choices, you guys, if x squared times y is less than 0, that means it's negative. What does that tell you?
Dot X would have.
Well, y has to be negative, and it doesn't really matter what x is because I'm squaring it, you know? So now I'm going to read through these. It says, if the value of y is negative, x is not a real number. I'm like, maybe. Let me come back to that. If x is a real number, y is negative. I like that. The sign of x is opposite the sign of y? No. Okay, a strategy, you guys. A lot of times I find counter examples. X and y do not have to have opposite signs. What if x is negative 2 and y is negative 2? That's still less than 0, so that's a counterexample. Does x and y have to be the same? No, that's dumb. Do they not have to be the same? No, they could be the same. In that example, they were. So let's look at this real quick. Y is negative as long as x squared is positive. And for x squared to be positive, it has to be a real number. This is B. Now, can x squared ever be a negative? In the complex number system, it can be, right? So when we first start teaching, like in Algebra 1 or Algebra 2 or something, we're like, oh, look, no solution. And we let you guys just stop there. We say no solution. But as we get further and further on, we actually go, oh, this equals, plus or minus 3i. So y is negative only if x is real. If x is imaginary, y could also be positive. Okay? I loved this question.
I like this. Let's go.
J. The answer is J. That's fair.
Say a prayer. Circle an answer.
The answer is J, okay?
Pair of natural numbers.
Okay, so let's talk about y. For every pair of natural numbers, A and B. So you guys, what does that tell me? Well, that means that A is like 1, 2, 3, 4, 5, da 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 da, and B is 1, 2, 3, 4, 5, da 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 da. Okay? I'm subtracting those. This is something called number theory. It's kind of fun. It's like you could prove that numbers are closed on the operation of subtraction, because if I subtract two natural numbers, well, natural numbers are not. If I subtract two natural numbers, I can get an integer, you know? So it's not the set of all whole numbers, because what if I chose A to be 2 and B to be 5, right? That's not a whole number, that's an integer, okay? But when I subtract those, I have to get an integer. I can't subtract two numbers and get a decimal, right? I can't subtract two natural numbers and get a decimal. It doesn't work that way. Now, how many of you put 2 and left it at that? Okay, that's okay. That is what I would have chosen. Honestly, that's what I would have chosen. And then you mark like letter F, right? Except, let's go back and look at our chart. If I have an integer, guess what? It's also a rational number. And if I have an integer, it's also a real number. And if I have an integer, it's also a complex number, right? So the integers are contained within the rational numbers. They're contained within the real, which is contained in the complex. So it's like all of them. That's why that one's really tricky, right? Those are the kids that are like, oh, I got a 36 on the math on my ACT. They're getting this crap right, you know? Okay? You guys good? All right. Let's talk about imaginary complex numbers real quick. Just because I think that this is super interesting and cool, I'm going to talk to you guys about this. Have you guys seen this pattern before? Okay, we know that I is the square root of -1, right?
It does happen to be the case.
Okay, which tells me what's I squared?
-1.
Yeah, and that's the most important one when you're working with problems and stuff, is to know I squared is -1, okay? All right, what's I to the third?
-1.
Negative I.
Yeah, I to the third is I squared times I, and I squared is -1, so it's negative I. Does that make sense? Yeah? Okay, what's I to the fourth?
-1.
1.
Negative.
Positive
No, wait,
1.
it's what the heck?
So I to the fourth is an I squared with an I squared, right?
Which is
Which is a -1 times a -1?
Which is 1.
Which is 1. With me?
Yeah.
Okay. I to the fifth. Now, I to the fifth is an I to the fourth times I, but I to the fourth is 1. And so every time we can pull out another I to the fourth, it's just 1. So it just goes away and it just goes back to I. And then guess what I to the sixth is?
-1.
Yeah, because it's I to the fourth times I squared, but I to the fourth is 1. So it's I squared, which is -1. And then guess what? It follows this pattern forever.
That is the most I've ever seen that pattern.
Isn't that cool?
Mitchell, you taught that amazing just now.
Cheers. Thank you, Ben. Okay? Therefore, every multiple of 4 in the exponent, okay, reverts back to 1. All right? This is something, have you guys ever seen anything in like different bases? Like we have a base 10 number system, right? Which means when you go up to 9 and then 10 is like the next one. There's binary, which is a base 2 number system. This is almost like, it's not a number system, but this is like a 4, because every 4 it repeats back to the beginning again. Okay? So if I asked you, what is I to the 121? Could you guys tell me?
It's I.
121. What's I to the 121? It's just I. Because what I do is I find the I that's closest to a multiple of 4, which is like I to the 120, which means 121 would be I. 122 would be -1. And it just keeps cycling. Does that make sense?
Yeah.
So you can take I to some ridiculously high power and figure it out by just taking out all the I to the fourth, because they equal 1. Okay? It's not going to get that complicated on the ACT, but I think it's interesting. So this kind of talks about I is the square root of -1, which we know is I squared is -1, I to the third is negative I to the fourth is 1, and then it repeats. So I to the fifth is I to the sixth is -1, etc. Okay? All right, simplifying with I. Do you guys remember back in the day when we would simplify square roots? We had 1 multiplies to make 12. 3 times 4, 2 times 2. So this is 2 root 3. Then this tells me it's an imaginary number.
Stick that I in there.
Yeah, I usually put it right there. Okay? Now, it would not be wrong if you wrote 2 root 3I. You won't see people typically write it like that, and here's why. Let's say I'm going like really fast.
That's what.
And let's say Ben, who has the worst handwriting, with maybe the exception of Dallin, let's say Ben is turning in his test, and he has this. I'm going to be like, Ben, is that in the square root or out of the square root? And we're going to argue about whether that I is in or out of the square root,
A
right?
or E?
Yeah, exactly. It's like, is it an A or an E? And don't make me choose.
Totally valid.
Dallin actually knows.
Did you give him the point or not? That's not.
No, I did not give him the
You
point.
can't put 2 answers.
Absolutely not.
It was clearly written as E, but A was circled. So.
It depends, but I really like marking down wrong. It gives me joy. Okay? It's just a thing. It's like, let's go, right? So anyway, you guys, so I usually put the I in between just to take care of that, like that ambiguity of whether it's in or out of the square root. So like 10 times 5, 2 times 5, pair of 5s. So that's 5 root 2, and I put the I.
Let's go.
Make
That's
sense?
actually kind of fun.
That's good. I do like those. I like
Factories are fun.
Okay. Adding and subtracting complex numbers, so easy, you guys. It's the same thing as adding and subtracting, like with like terms. These are the imaginary parts. I put them all together, right? 6i minus 2i plus 3i is 7i. This is the real part. I don't add that together. That's it.
I'm just a variable.
Wow. All right. Now, you're going to learn something new in just a minute here. Don't worry. Okay, when you're multiplying, though, you can't just multiply the real and multiply the imaginary. You have to FOIL. Now, if you guys like to do FOIL like that, you can. With I's, I almost always put it in the box just because it makes these cool patterns. Yeah, box gang. Let's go. All right. And you multiply it out. I just like to do it like this because it helps me stay organized. So look, I get 1 times 1. That's 1. 1 times I is plus 1i. Negative times I is minus 1i. And then that's minus I squared. Now, this particular one, those cancel out. And what is negative I squared?
1.
Positive 1. So 1 plus 1 is 2. Okay? All right? So this one, I would do the same thing. However, guess what? This is amazing. That's funny. This graphing, I haven't heard that since the 3rd grade. This graphing calculator will actually do I problems. Can you believe it? Yes, it will. There's one of like 2 things that I think the graphing calculator does better than a scientific. All right? This is one of them. Do you guys see the I button on here? Okay, do you see the decimal point? You see an I right above it? It's not the capital I, it's not I, it's I. Right? Look for lowercase I.
So cool.
Now, check this out, guys. Type this in with the parentheses. Parenthesis 1 plus second I. Parenthesis 1 minus second I. And what do you get on your calculator?
2.
You get 2. Here, I'll show this for our viewers at home. For our viewers at home. Did you guys see that? Right? Okay. And here's the I. It's right over the decimal point. Boom. You can just type it straight in for our home viewers today. Okay? So, guys, guess what? This problem, I am definitely not going to do that by hand. That would be lame. Can you guys type that on your calculator? Yes, but they give us a calculator, so come on, right?
Didn't use the calculator, Miss Mitchell.
That's fine, but you'll waste time.
Wait, so how do you use the calculator?
Ooh, there we go.
How do you?
Okay, so we type in I and then parenthesis 2 plus I and then a parenthesis 3 minus I. And it just gives me the answer right there. Guys, what do you get for your answer on this one?
No, you don't have to. Yeah, it's 7I minus 1.
Yeah. Okay?
I hate the placement
Cool.
of that.
Now, there is a way that they can force you to not be able to use your calculator, and we'll see in just a minute how they do that. But, guys, I could have used my calculator on that. Now, I wouldn't have because it would slow me down, right? That's a lot of typing when I know how to add 6 minus 2 plus 3. Of course, some of you don't know how to add 6 minus 2 plus 3, so maybe use your calculator. Okay. Now, guys, dividing, guys, listen up. Okay, dividing by a complex number is actually very, very tricky. You have to multiply the top and bottom by what's called the complex conjugate. It gets very confusing. Guess what? We're not doing it. We're going to do calculator stuff on this.
Just
Okay?
look that up.
You could.
Do 4 over I plus
You'd still
1.
have to conjugate that times I on the top and bottom, so it'd be 4I over negative 1.
Oh!
So you can, but your calculator will do it. Okay, guys,
I like doing that.
real quick. Do these both on your calculator. Now, if you're going to type it in using the divide by symbol, make sure you put a parenthesis on that. Divided by I. There's a way to do fractions in your calculator, and I try to train you guys to use this button because as our expressions, like especially in calculus or whatever, get bigger and bigger and bigger and crazier, it's easier if you know where the fraction key is. And the fraction key is under alpha y equals. There's a little menu and it says like that. And it makes a fraction for you. And so if you use that, you don't have to worry about parentheses, okay? On the second one, if I want to type it in like this, I got to go parenthesis divided by parenthesis. Or you use that secret fraction button, and then you just type this in, okay? So go ahead and do that on your calculator. Show it both ways. 4 plus I divided by I. Okay, and do this as a fraction. 1 minus I, 2 plus I. All right. There we go. Okay, so that's writing it one way with the slash. That's writing one way with the fraction button. All right. So guys, did you get, for the top one, 1 minus 4i? Yeah. For the bottom one, did you get 1/5 minus 3/5 I?
I got a decimal.
Yeah, mine did a fraction. If yours did decimals, I want you to hit this real quick. If it goes 0.2 minus 0.6 I want you to hit math 1.
Wow.
If I got it in decimals and your answers in fractions, your calculator will even do fractions with complex numbers. It's amazing.
Wait, will the ACT have all of the answers be fraction values?
Usually they're in fractions, yeah. So if I hit math 1, it'll turn it into that for me.
What does math 1?
Math 1 will turn everything into a fraction, even complex numbers. So if you hit enter and you get that, and then you hit math 1. Okay? There's some more calculators back there if you want to practice. All right. You guys, this is so fun. I have probably, maybe once every 4 years, they'll put a question like this on here, but whatever. Let's talk about it because it's so cool. With the complex number plane, you actually have an axis where this is the real and this is the imaginary. Okay? And the axis is like, the way that you plot a number in a plus bi form is like you just plot it as a point. So the point negative 2 plus 3 goes over 2 on the real axis, up 3 on the imaginary axis.
That should be illegal.
I know, but that just is what it is, and it's pretty cool.
That is really cool.
Negative 2 plus 3i, it plots the same way as the point negative 2 comma 3. Okay? It just does. It's cool.
It's just
The I just means it's on the I-axis, and this just means it's on the real axis and the imaginary axis. So I go over, 2, up, 3.
it's
How
just
much are we gonna see this on the ACT?
Not, but it's so interesting. I want to tell you anyways. It's really cool. You guys will
a
like
good way
it.
to
Now,
hold the data
Guys-
in visual form.
I know, but just think of this as something fun. When we do absolute values of numbers, like an absolute value makes every number positive, right? But you know how I'm always stressing with you guys, that's not actually the definition. What's the definition of an absolute value of a number? The distance from 0, right? 2 is 2 away from 0, negative 2 is 2 away from 0. How far is this from 0?
6.
Oh,
Square root of 3x.
that far. Yep, you're on the right track, Andrew. That is that far away from 0. Okay? And how can I find out how far that is? Well, could we make a triangle and do a little Pythagorean theorem?
Wait, no.
So like a squared plus b squared equals that distance squared. So 4 plus 9 is distance squared. So it's the square root of 13. So if you said to me, hey, what's the absolute value of negative 2 plus 3i? I could be like, oh, it's the square root of 13. I could be like, what?
That's so cool.
But it's because the distance from 0, right?
That's such a smart.
Do you want to see something even cooler?
Yes.
Grab your calculator. Okay. Go to absolute value, which is under alpha window. Right? Where it says abs. Alpha window, abs. And type in the absolute value of negative 2 plus 3i. So we're typing in the abs on the calculator, negative 2 plus 3i. What's that in absolute value? What do you guys get?
3.605.
Type in square root of 13. What do you get? Yeah.
It knows.
So your calculator will actually do absolute value of complex numbers, which is so crazy because it's doing a distance formula. But it's still pretty cool, I think.
I wonder what that looks like in the calculator.
I don't know. I don't know if it's programmed with a distance formula or not. I don't know. Anyways, you guys,
Do that other formula
Probably
that's the
not.
same thing
Prob-
over
there's
and over
probably a
again.
more-
It can't do Euler's formula.
complex numbers, look. 0 to 1 per test. Sad, but they're fun.
I think there's gonna be 60%.
No, they're gonna be good though. So let's try this. I'm gonna say number 1 is easy because you have a calculator. I'm gonna say number 2 is medium. And I'm gonna say 3 is kind of hard. Here's why. They are forcing you on number 3 to not use your calculator. Do you see how?
There's an X.
By putting a variable in there, they're making you multiply it out, which is like, come on, bro. But they're making you do that one by hand.
Do you want us to do 4 and 5 as well?
Yeah, and then 4 is total calculator. And 5, you could do it by calculator or by hand. It's really tricky. Let's see who can get it, okay? So yeah, I want you to do 1, 2, 3, 4, 5. Use your calculator on as many as you can. On your mark, get set. Let's go.
Miss Mitchell, what if you don't want to do number 3?
Then skip it.
Wow,
I don't
that's
know.
unfortunate for you. But
What are you going to do if you don't want to do it on the ACT?
You skip stupid, and then in the last 2 minutes you go by.
That's right. You put a little thing next to it, and you hope you have time at the end because it's 60 minutes and 60 questions.
Yeah, that's
60
when the
questions,
last
60
minute you
minutes.
just kind of.
Yeah, that's fair.
That's
That's fair. However, if you're trying to get a 36 on your math, anybody here trying to get a 36 on their math?
I'm trying to get a 30.
Yeah.
I've already gotten a 38.
There's quite a few of you. Wait, who got a 38?
You can't get a 38.
There's no 38.
Yes, no, you did. You somehow did.
I mean, Henry could get a 38. There's
Exactly.
no 38.
Exactly. Out of 36.
No,
Okay.
you can't sit there.
No, it's
Can I go for the test?
I don't know what you're talking about.
I swear it does.
It totally works.
Have I ever studied for history? No. But you know, by some miracle I was gonna 100.
Sleep on your ACT packet or something.
Seriously.
Okay.
No, hey.
Three kicked me off because how dare they make me factor?
I know. That's why they do that.
I don't care about the multiplying. The factoring's BS.
Oh, but the factoring's not even that bad.
It's not
You know,
that
we always
bad,
look
but I just don't want to do it.
at like the reals are here, imaginaries are here, and I think that's what they were trying to do. But yes, that's why I said.
Don't make me like hold it. I mean, I got
Don't
it.
make me lose my temper.
If I get the wrong answer, I'm alright. I'm setting something on fire.
It's not negative.
I'm setting the Buford statue in the main hall on fire. Oh, are we supposed to be doing 4 and 5? Wait, are you saying that I should commit an act of terrorism towards Mountview High School?
No. Certainly not saying that while the recorder is on.
I was gonna say this doesn't seem like a good idea for either you or me.
All right, you guys ready?
No. Okay. There's one something against me, but I have no idea what number 3 is.
That's fair. Just guess.
The calculator didn't even help.
Yeah, number 3. The calculator won't help.
Yeah, just give me 2169. I was like, where'd the X go?
What?
Where'd the
Because
X go?
you can't use an X when you're plugging in your calculator because your calculator has some random value stored in X that it's using. So you can't use that. That's kind of why I put you had to do that one by hand.
I didn't want to do that. I didn't want to do that. Almost as bad as calculus, Mitchell.
Oh gosh. Okay. You guys, for number 1, did you type that directly into your calculator?
Yeah.
And did you get C?
Yes.
Beautiful. Now, for number 2, I did notice something. I cannot type that in my calculator.
I know, I tried it.
Did you try it too? I tried it too. And I was like, ugh, lame. But you know what I can type in my calculator? Square root 80i and square root 125i. I can type that in. Exactly. And you can simplify the thing down, but I could totally do it this way. Okay?
It was kind of fun to do by hand though.
I tried to do my head, but failed.
Now, when I type this in, I got to do square root 80, and I do have to put the I outside the square root, right?
Oh, bro, just put it in.
I'm sorry. So you can't go square root 80i. The I is out here, okay? And then you type square root 125i, and the I is on the outside. Whoa. Square root 125i. Okay? And when I did that, I got this. Right? So guys, how can I figure out what answer it is? Yeah, just plug in all of them. Now look, it certainly did not give me a negative, right? The square root of 5 can't be 20. I mean, you can type it if you want, but the square root of 5 can't really be 20. Can 9 square root of 5 be that? So let's type in 9 square root of 5. You can type it without the I. I guess you can type it with the I. It doesn't really matter. With or without, that's what you get. Okay, so it's that one. So I can do that on the calculator.
It's gonna be hard to like
Go back and forth on the calculator stuff.
no, just the reflexes to not do it on the
I know. The reflex is to do this. Which works.
The issue is it's fun, but it's more time consuming.
More time consuming.
How would you do that by hand?
Yeah, I would do this. I would take the 80, and I'd go, okay, that's 8 times 10, that's 2 times 4, that's 2 times 2, that's 5 times 2. And I got pairs of 2s, and I get 4 rad 5I, and then 125 is 5 times 25, which is 5 times 5. So that's 5 rad 5I, and then 4 rad 5 is 5 rad 5, it's 9 rad 5.
Exactly, that's what I was.
And can I do that faster than in my calculator? I kind of can, so it's not a bad way to do that. You just have to simplify, do factor trees on those. Okay, this one, like I said, it forces you to do it this way.
Wait, so how do you get, I have the number.
Yeah, so I look at each of my answers right here. And first of all, you can tell it's not these two because it's not negative. So plug in root 5, 9 root 5, 20 root 5 and see which one it is. Make sense?
2 and 40, 2 and 20, 2 and 10, 2 and 5.
Now, okay, when I do this one, guys, I get 4x, I got 5ix, I got negative 16i, and I have negative 20i squared. Now,
You mean 20?
this, and then negative 20i squared turns into positive 20. Now, let this be a lesson to you. I'm going to teach you guys something really quickly that would have helped Ben. Okay?
Shut up, Nick.
You don't just go, I'm going to solve, I'm going to solve, I'm going to solve, I'm going to solve, I'm going to solve. Right? You get to a step and you look. You get to a step and you look. You get to a step and you look, right? Because you might not have to go as far as you think you do. So when I got this, I started looking over here and I said, well, look, I have to have a 4x, right? You guys see that? I have to have a 4x and I have to have a plus 20. That one's a minus. That one's a minus. That's a plus 20i. Gotta be that one. And then I was like, let's make sure it's gonna be that one.
Why did we switch it?
Because I squared is negative 1. So I squared means it's negative 20 times negative 1. So this, look what it's doing, you guys. It's putting the real numbers together, that's those. And it's putting the imaginary numbers together. 5 minus 60. 5x minus 60.
one with a positive 22, so.
So it's the only one with a positive 20. So if you felt good about that, you could just narrow it down, you know?
I forgot that it switched to
Or you could do Ben, who's a fantastic math student, and sat here and wrote this entire huge polynomial and then had to factor it back out to get that.
It's kind of fun.
Which is amazing, but that's what my people that are used to just going nuts on the test, right? So you got to make sure, okay, can I get there faster? That's what we're always talking about. Can I get there a little bit faster?
Wait, Zach, is that what you did?
Hey guys, for straight calculator. Now the first time I put this in my calculator, I think I got 0.6 plus 0.8i. Did you guys get that?
I
I think
did.
so.
Some of the calculators will do decimals, some of them will do fractions.
Then you have
Okay.
to change it to a fraction.
Yeah, then you just go math 1 and it'll change it to a fraction. So,
Which if you
1
use
plus
two
I
separate
over 2 minus 5. Okay, and I got this. 0.6 plus 0.8i. And then I hit math 1. And I got 3 over 5 plus 4 over 5i. Okay? So make sure that you know your calculator. Being able to turn things into a fraction, I use that so much. All right. Here's the long way to do this question.
There's a short way?
Yep,
There's a short way. Why don't you teach us the short way first?
I will, but so you understand what you're doing. 3 plus 5i plots over 3 up 5, right? That's 0 minus 2i. That plots over 0 down 2.
Okay, this is what I did. Now
And then the distance, you'd have to like maybe, I guess, make a triangle there and do your distance formula. Distance from here to here is 3. What's the distance from there to there? 7, because it's 5 and 2. And then I just did 3 squared plus 7 squared, I did the square root. Okay? Okay, here's the fast way, you guys. How do I find the distance between something? Let me ask you this easier.
Subtraction.
I'm at mile 2 and I need to get to mile 10. What distance is that?
8.
And how did you get that?
Subtraction.
10 minus 8, right? Just subtraction. So what I did was in my calculator, I did that minus that. Because I know that the difference between things is just subtracting, okay? So if I get 3 plus 5i minus negative 2i, I got 3 plus 7i. That's the, and then for distance, we got to do absolute value. So then I tossed that in an absolute value, and then I was able to find it.
Wait, why are we absolute value?
Because it's distance, so when I subtracted that, I basically moved this triangle to the origin, then I saw it's fine.
So
We made it.
wait, so when you subtract, I think I get what you're getting at there.
So the distance between them, so
The distance is 3 plus 7i. Right?
yeah, what you're actually doing, shh, don't tell them right there, is you're actually finding this vector right here, and this vector is the vector 3 plus 7i, and you're moving that vector to the origin, and then you're finding the distance of it. That's what you're doing. We're gonna talk about vectors in a minute. Like you take, like, this vector was right here, right? And then this vector was like up here. And then we got this resultant vector, and I'm taking that vector and I'm moving it to the middle, and then I'm doing distance from it. But
Remind me
we'll talk
how
about
we're
that
moving
later.
it to the middle though.
Wait, so,
So it's 58. Square 58.
Miss Mitchell, so how are you able, so why did you combine instead of subtract?
Distance for you guys remember distance formula between any two things is the square root of a squared plus b squared. But because this is two different like two different vectors, I had to find the space between them first.
Okay.
That's kind of confusing. Okay. Anyways, let's talk about translation. This one has the most on the test. You guys can kind of read through these. Most of these you're going to know, right?
I remember.
Plus, sum of, increased by, or more than. Okay? Minus, difference between, decreased by. Now, you guys, there's a couple exceptions I need to talk to you about. If I'm doing a word problem and I say that, like, Delano's age is 8 years less than my age. How do you put that into an equation? 8 less than x.
Miss Mitchell, you're in your like 20s?
Yes! Thank you! I know!
Well, you don't look a day over 19.
I know. Okay? Thank you. So, when you see less than, you have to flip it. I don't mean less than as in like the little symbol greater than less than. I mean, if you're saying it's 8 less than x, you have to flip it. Now, why don't I have to do that for x more than y? I mean, technically you do x more than y means it's y plus x, but that's the same thing, either way, right? Okay, so less than you have to be careful about. The other two I always have to be careful about is at most, at least. Ugh, those bug me. At most and at least, for some reason they just really piss me off. So that's how I think of it. I'm going to the grocery store and I want to spend at most $20. How much can I spend?
20 or less.
Or less than or equal to, and then at least isn't on here, but at least I was going to say something on I'm going on a dating website. I want to date someone that's at least 18 or older. Greater than or equal to. I don't know, guys. I'm like kidding. Anyways. Just because you know. Okay, at least greater than or equal to. You know what I mean? Okay, so I don't necessarily want to take time doing all these. I just want to go straight to the questions. All right. How are we doing on time? I want to zoom through this, so we'll do them together.
Well, we still have half an hour.
Yeah, but I want to spend some time on matrices and vectors because they're so interesting. Okay,
It's a fun math day. I liked it.
agreed. E, guys, what does decrease by mean? Minus. And then the sum of f and 12. Now I know the sum of f and 12 is f plus 12, but what's the problem with this? The sum of, yeah, when it says the sum of something, you do have to use parentheses, so be kind of careful with that one. All right. Okay, that one's pretty easy. Okay, to attend a professional training seminar, members pay 100, non-members pay 125. So members 100, non 125. What are the total fees for 13 members? 13.
What's the answer?
And K non-members. Oh, the answer for the first one is B. Okay? 13 members and K non-members. Which one's it going to be?
Okay.
K.
That's not confusing whatsoever.
All right.
That's bad as one with the heckin' E in there. Getting calculus non-flashbacks.
Mary made brownies for her family, so she made a bunch of brownies. Hey guys, how would you figure out if you ate half the brownies? Like, let's say I made 100 and I ate half. What is that? 50. You times a half. And I could, trust me. All right? And then another half is times another half. And then another quarter is times another quarter. And at the end, they had 6. Can you guys, like, backwards, reverse think about that?
Just like,
Multiply by 8.
Basically, well, multiply by 4.
Oh, but it's
24 times 2. 48 times 2. 96.
I just did 24 times 2 times 2.
Yeah.
Because if you know your 12 times tables,
It's not too bad. And then I could check and I could make sure it works, okay?
12 times tables
That's
is
fine.
the greatest thing I've ever learned.
Okay, now. Sorry, so number 2 is K and number 3 was E.
number 1 is D.
And number 1 is B. Yeah. Okay. Number 4. Is anybody bowl in here? Is a game really called a string? Because that bothers me. A string of bowling? Like,
This is what the internet's for.
Google it for me. Say, what is a game of bowling called?
I would call it a game of bowling.
I would call it a bowl.
All right, let's give that a Google. All right.
Did you just say that?
Yeah.
No.
5 games cost me $12, right? And then extra games cost me $3. Okay? Without looking at the formulas just yet, guys, how much does it cost me to play 9 games? Can someone tell me how much it costs to play 9 games?
Okay, well, the question is just wrong. It's just matches or games.
Okay, so, how did you get 24, Audrey? You were saying it. You did 12 plus.
12 plus 3 times 4.
Now, where's the 4 coming from? I don't see a 4 anywhere.
Because 9 minus 5 is 4.
Okay, so it's the number of games you played minus what you already paid for, right?
Yeah.
So when I give you 5 for a certain price and the extra costs more, you need to call this X minus 5 because I already paid for those 5. Does that make sense? So a lot of word problems do that. So it's like if I already paid, Ben, do we know what a string of bowling is?
I'm not seeing anything about this. I don't believe this exists.
I think you might be right.
It might be
It
reference.
might be the amount of frames. Maybe 10 frames.
It might be that because sometimes they use like strings attached.
What is
to
a
bowling.
string in bowling?
When I googled that, I found that sometimes they use strings attached to the pins to like prop them up.
Oh,
on the back.
yeah. Oh,
so
that's
it's
weird.
probably referencing like the act of.
It's strings attached to the top. Oh, that's so
So it's
dumb.
probably
I
like
hate it.
5 strings.
That's not every bowling alley.
Yeah. So like.
certainly not.
What is this?
So I got H for that one, okay, guys? Okay, same idea. I have a moving truck that charges $69.45 per day, and it includes 50 miles of driving.
Wait, I just googled it and it says that
Does it
What
say
a
the-
game's called in bowling is called a frame.
Yeah.
Wait.
String. It's
Neither
fine.
of those
Go
make
back.
sense.
Wait. Go back up to it for a sec.
One can play 5 strings of bowling.
Oh, so that is a
I thought it was maybe a string of strikes.
Well, anyway, we're getting a little off track. That's my question. Okay, I don't think so. And then any mileage over 50 is 29 cents a mile, and we're going 3 days and 600 miles. Can I assume that I do 200, 200, 200? You guys fine with that?
Wait, sorry, I didn't get all that.
Okay, because I'm driving for 3 days, so I'm doing 200 miles a day. That's what we're gonna do. So each day I pay $69.45 for the truck,
Nice.
and I pay 29 cents for the additional miles over 50. So how much am I paying? 150, because I already paid for 50 of them. And then the next day I pay $69.45, and then I also pay 29 cents for 150. And then the next day I pay $69.45, right? And then I pay 29 cents for 150. And then I just add all this up, okay? Or I could just add up 1 and multiply by 3, right? So every day I'm $69.45 to rent the truck. I'm only paying for 150 miles because they gave me the first 50 free, and I get $112.95. And if I do that for 3 days, I get $338.85. Okay? All right. They just
What a
went
missed
over.
opportunity.
Totally. All right.
Sorry.
A university surveyed its students about their modes of transportation. 350 people responded. 232 wrote they use public. 113 wrote that they use their personal vehicles. And 57 said they use both. Now the problem here, guys, is that there's some overlap. You guys see that? It's not like you can either pick public or personal or I walk or something. There's an overlap here. Whenever I'm doing a problem that has an overlap in it, you know what I use?
A table.
A Venn diagram.
That's what I mean.
Yeah, good job.
You guys know what a Venn diagram is?
Oh.
That's a Venn diagram.
What's the question asking?
Oh, how many of them used public, personal, or both? If I add all these up, it's not going to
Wait,
be.
like they used like both of them? They've used public and a personal one?
Yeah,
Wait,
they.
couldn't you just add 57 to both of the numbers and go from there?
No, because 57. There's duplicates in here and there's duplicates in here.
So why don't you subtract 57 from both of those and add it together?
Kind of. I'll show you. Okay.
This is classic.
Guys, what do I put in here?
Both.
57.
Then you just add the public and
Not exactly. So the 232 is including those 57 people. It's not, it didn't say like I used both, like, and not this one. It's like I just marked both.
so add.
So if I take 232 minus 57, I get 175 that use public only. And then 113 that uses personal also includes the 57. So if I did 113 minus 57, I get 56. So how many use public, personal, or both? Those are the numbers I add. 175 plus 57 plus 56.
That doesn't add.
281. So what's
Yeah, 280.
in there?
Now,
Oh, I see. Okay.
I can tell that some of you guys want to just like have a formula for it. All right, Aubrey, I got you. You ready? A union B. We talked about this. Union is everything all together. So A union B is all of this, okay? It equals A, everything in A, plus everything in B, minus the overlap. Because you're double counting the overlap. So if you want to do it that way, you can, but that takes a little bit of thinking. But does that make sense? The whole Venn diagram, A and B all together, is everybody in A plus everybody in B minus the overlap one time because you double counted it. You counted this overlap here and you counted it here. So that's a set theory way to do it, but I would probably just draw it up. Okay, make sense?
I don't like that problem.
All right.
It feels so good to understand math.
Right? Okay, guys,
So true, though.
matrices, now look, 0 to 1 per test, so it's not a huge deal. However, they are so easy. If I take 5 or 10 minutes to explain you matrices, you'll get the questions every single time, okay? They will ask you one of 3 things. If they ask you an adding or a subtracting question, golden, man. Those are so easy. They have to be the same dimensions. That's a 2 by 2 plus a 2 by 2. And it basically goes like this. The top left plus the top left equals the top left, like that, right? The 2 plus the x would equal that. When you're adding or subtracting, you just add the elements together, like that. Does it make sense? Which means that if they don't have the same dimensions means how many rows and how many columns, if they don't have the same dimensions, you can't add them together, okay? I can't add a 2 by 2 with a 3 by 3. You just can't. So adding and subtracting is exactly the way that you would think it is. So is something called, I'm going to add this because it's on there sometimes, scalar multiplication. Okay, a scalar is a number. When we're talking about matrices, a matrix is a set of numbers, a scalar is a number. So scalar multiplication is like 4 times that matrix. What do you think you would do to do scalar multiplication?
Multiply them all by 4.
That's exactly
It
what you do.
scales it up by 4.
Exactly. You just multiply each element by 4. That's called scalar multiplication. It's exactly what you think it would be. So if you ever see a scalar multiplication question, you're like, dope. If you see an adding or subtracting, great. There are 2 things with matrices that are tricky: multiplying and determinants. Okay, real quick, I'm going to talk about multiplying. What I want you guys to remember with multiplying is row times column. Row times column, okay? This shows you the pattern, and it's a little bit tricky, but let me show you, and I'll use different colors. I take that row times that column. Now, how do I multiply a row and a column? You go like this. 1 times W plus 2 times Y, and that goes there. So, row 1, column 1 gives me my 1, 1 element right there, okay? And then I do this. Row times column gives me that one. So when I do row column, I do 1x plus 2z. It's just using numbers and letters to kind of show you. Do you guys see what the next row column would be? 3, 4, and wy. So 3w, 4y. And then the last row column would be 3, 4, xz. 3, 4, xz. Row times column. Okay?
Would you be so
Now-
kind to tell us why that is?
I would not, because I don't know if I remember why it is. That's just how you multiply matrices.
We're all in the dark a little bit here.
Google it and tell me on Monday. Dude, I'm in matrices. Hold on. Okay, now check it out. Guys, let's say I have a matrix. Okay, this is what's called a 3 by 2 matrix. All right? A 3 by 2. Let me make another matrix. That is also a 3 by 2 matrix. Now let me ask you a question. Can I multiply row by column? Why not? That's 2 and that's 3, okay? So in order to multiply, and this is kind of the only thing that they ask you usually, the row of this one, which is 2, and the column of this one have to match. And you see how that and that don't match? So I can't multiply it, okay? So if you read down in here, can I multiply a 2 by 3 and a 3 by 5? Can I multiply them? I can't add them, but can I multiply them? Yes. And you know what I'm going to get once I multiply them? A 2 by 5. That's how it works. That's cool, right? By the way, these will do matrices, but it takes a bit of time. It's under second and then the x to the negative 1. And I'll show you later if you want. All right? So, like, this is a 2 by 2 times a 2 by 2. Am I allowed to multiply them? Yes. The answer will be a 2 by 2. Okay? And let me just show you one. We won't do too many. Let me just show you one. Row times column. What would it be? Okay, so 3 times 1, 3. 0 times 6, 0. 3 plus 0, 3. And you just go through and fill them out.
Why are these useful?
Oh, matrices are so useful, actually. Did you guys
It's
ever
data.
do...
It's just a nice way to hold data.
Right, have you done minus 2z equals 11, 4x plus y minus 3z equals 12? And you have to solve a system of equations with 3 variables and 3 equations. You could do it with matrices. Or even a system with 2 variables and 2 equations if we want to go. This is 3 and 3. But let's say I have 2 variables and 2 equations. I can actually solve this by making a matrix. And I can solve it that way. And it's actually pretty cool. I could teach you a month on matrices. After the AP test, if you want, I'll teach you matrices. They're so fun. All right, anyways. Guys, this is a 3 by 1. Okay? This is a 1 by 3. Can I multiply these together? Yes. And when I do, what am I going to get? A 3 by 3. And that's kind of all you need to know. Okay?
So you take the first and
Yeah, the outside's main. Yeah, and this one, if I did row times column, it would be 3 times 2, so that's 6, that goes up there. And then row times column, that's 12, like that. All right? You'll see when we get to the questions, you'll see. The last thing about determinants is there's something called a determinant. Let's say you have no clue what a determinant is. It will always tell you that formula. So, I bet without even me telling you what a determinant is, can you guys find the determinant of that matrix?
-2.
The determinant of that matrix is -2. Do you guys see how I got that?
Yeah.
Okay, look at the pattern. So, if it ever asks you for determinant, it'll give you the pattern. Look, it says it's equal to A times D minus B times C. Okay? So the determinant of this matrix is 1 times 4 minus 2 times 3.
Which is 4 minus 6, which is -2.
Do you know what that is? No. Can I teach you? Yes, but it would take forever. It doesn't matter what it is, you can find it. Okay? All right, so this is a sum question. You guys can do that. This is a determinant question, but it tells you what the determinant is. And then it's a multiply question. 2 multiply questions, actually, okay? So, in the 5 minutes that I just taught you matrices, let's see how many of those you can get right, okay? Make sense? We didn't go over a ton of matrices, but I went over a little bit. Let's see how many of you guys can get right.
Mitchell, the explanation for why we can multiply these is not simple whatsoever.
Right, that's probably why I don't know, and I probably learned it at some point and was like, that's crazy.
It's wacky, and
I just know that it
it's
works.
either a 17-minute long video or a very complex Khan Academy article that I would have to read. So I'm gonna
Yeah,
pass
too much
on
for my
that for
brain.
now. I can send it to you though if you really want.
Not really.
Alright, I didn't figure. We can revisit that discussion at another point if we're both interested. Although I have my doubts.
right, did you guys get some answers here? Alright, let's check it out. I feel like that's pretty easy. Look, if I take A plus B, so the top left one should be 2, right? So it can't be that bad or bad. Okay? And then I did this one, and that should be 0. They're both 0, that's annoying. Okay, so I did this one. What's 0 plus 1? So it's got to be B. Okay? So by knowing that adding and subtracting, you just add or subtract the elements, you guys will get that right. Easy. Okay, this, even if you didn't even know what a matrix was, if you could follow a pattern, you could do this. It says if DET, if you don't know what that means, is AD minus BC, then do the same pattern for here. What would it be? Negative A, negative C, minus BD. Okay? So a negative times negative is positive. So I got AC minus BD. Did you guys get that? Okay?
Just because
Just
because
because
the D and the C switched places.
Oh yeah, they don't just try to like
They
plug in, look
they
for the
remix
pattern,
them.
and the pattern goes diagonal minus diagonal. So then just go diagonal, which is a positive AC minus diagonal. Because it switched stuff around, right? But it's just about following a pattern. So if you need to know what a determinant is to do that, no. You don't even really need to know what a matrix is to do that. Okay? Guys, the only thing I need you to remember for multiply is row times column. Row times column.
Does it matter which one is row?
Yeah. Now, let's practice. We only need to find y, but let's just practice on this one, okay? Okay, so look, let's do this first. Row, column. Okay, what's 2 times 4? 8. What's 0 times 3? 0. 8 plus 0? 8. So that would be what W is, right?
Oh, I can't.
See how that works? Okay, row, column, right? Row, column. What's 2 times negative 2? Negative 4. What's 0 times 9? 0. Negative 4 plus 0 is negative 4. Okay? Let's do row, column, right? Negative 1 and 4? Negative 4. 5 times 3? 15. Negative 4 and 15? 11. And that's what y was.
Bro, for some reason I couldn't figure out negative 4 plus 15 was 11.
I know. Like a lot of times I'll actually be, like when I do actual matrices, you'll see me like writing that down. Just so I don't mess
Well,
up.
I did.
But-
I was like, that doesn't,
Well, then
that's
I
not
can't
an
help you.
option on there.
And then let's just do the last one for funsies. Boom, boom. So what's negative 1 times negative 2? 2. What's 9 times 5?
45.
Add those together, 47. So even though there's only one possible, probably only one matrix question, you guys should get it right now because
That's true.
matrices aren't too bad. Yeah, that's all right.
Are we gonna get
Okay.
one before?
Possibly, but it's not that bad, right? Because, okay, can I multiply row, hold on a sec. Sorry. Can I multiply row, column of that one? Yes. Can I multiply row, column of that one?
Yeah.
Okay, what about row, column?
Yes.
Row, column?
Yes.
Row, column. No. You guys see that? Row, column. I can't do it. It's undefined. The other way is you could say this matrix is called a 2 by 2. This matrix is a 3 by 2. This and that don't match. So a 2 by 2 and a 3 by 2 don't match. So I can't multiply this. All right? Just to see if you understood our little mini lesson on matrices real quick, you guys. Which of these could I add to M? Which of these could I add? Only G. That's right. Because adding, they have to be exactly the same. Multiplying has to be row column. Okay? Matrices are fun.
Only the first.
Let's talk about vectors. You know, you guys are like annoyed that we could put complex numbers on a graph and have it be the real axis and the imaginary axis. Same thing with vectors. Same thing with vectors. When we put it on a graph, like the vector, okay, I could write this 3 plus 4i would go, sorry, that's complex. The vector 3 comma 4 goes over 3 up 4, but it's like the vector. Okay? Guys, that's one way to write that vector with the little brackety things. Another way to write that vector is 3i, 4j. I is the x part and j is the y part or whatever. So a vector is simply something that goes like over this many, up this many. That's a vector. Okay?
Direction.
And magnitude, right?
Oh, yeah.
Your vector. Oh, yeah. Thanks, guys. Thank you. So it does. It has direction and magnitude. Now, guess what the magnitude of a vector is? The absolute value. It's the distance. Yeah. This particular vector goes over 4 up 5. The magnitude of that vector would be the square root of 41. Okay? And vector has direction and magnitude. All right. Look, magnitude, distance formula, blah, blah, blah.
Wait, like that's actually it?
Yeah.
Yeah. Wait, that's amazing. I'm actually gonna remember it then.
Yeah, no, it's dope. So it's just the same thing as like when we were doing the absolute value of a complex number. It's the same thing as the magnitude of a vector. It's just using that Pythagorean theorem, you know? Now, I took this class in college, and I swear I only remember one thing from my vector class. Okay?
You had an entire
I did.
That's awesome.
I don't know if it was an entire class, but like... Okay, so like this is the vector 2, 1, because I go like over 2, up 1, right? And then this is the vector, like let's say negative 4, 4, down 4 over 4. Literally the only thing I remember about my college class is he would drill this into us. If you line up your vectors head to tail, you make a resultant vector. Look, so if I put that here, and then I put that here, my resultant vector is that.
Are you kidding me?
Head to tail goes head to tail. That's what I remember from my vector class. Yeah, it's a physics thing. So if this vector is 2, 1, and then this vector is negative 4, 4, and I add those together, what do I get? Negative 2, 5. This vector is going to go down 2 over 5. That's how vectors work.
We went over this in physics.
Yeah, if you've done physics, you can do this, but it's not that bad. So like the resultant vector, you can literally just add the parts, and then it goes like 2, 1, negative 4, 4, whatever. Anyway, so let's look at, oh yeah, so see, I like to do this. Okay, tail to head, tail to head. If you line them up, the resultant vector goes tail to head. It's like that.
It's like you've got a distance and then
I mean, it's almost like that, right?
distance and then
It's almost like if I went 120 on the x-axis and then 50 on the y-axis, I would have gone 120 on the x and 50 on the y. Vector stuff is simple.
What are ourselves our distance and our displacement? Something I've seen in calculus before.
Now, the sum in vector notation. Well, you guys, if you can write this vector in something I and something j, and then you can write this vector in something I and something j, you can just add them together. All right? And the I tells you where it goes on the x-axis, which is left, right, and the j tells you go to where on the y-axis, which is up, down. Right? I think that's right. Okay? So this vector mn, what would we call the vector in ij notation? 4, 0?
Yeah.
Because it goes over 4 up 0.
That's what I thought.
And then this factor ij, how does this one go? Down 3 over 1.
It goes over 4?
1, 2, 3. Yeah, from here to here.
Oh.
Yeah?
Wait.
And this one goes down 3 over 1.
What's that?
So what's the vector 4, 0 plus the vector negative 3, 1? Vector 1, 1. Wait, what did I do wrong? Oh, is this the vector 0, 4?
Yeah.
Dog.
You gotta
I've
do
been
it
teaching too long
opposite.
today. That's the vector 0, 4. 0.
So,
Hang on.
wait, is I rise or is J rise? Because you did one of them flipped.
I think I flipped my thing up here. Just hold on.
Because I'm not, I can't remember. Is I rise or J rise?
A is the X component, B is the Y component.
Okay.
Pretend I didn't say
J
anything.
rise.
Somebody
So
rewind
it's
the
4,
video.
0 and 1 negative 3. 4, 0, 1
It's
negative
basically like this, and this is what I should have done. It's like plotting points from 0, 0. If this were 0, 0, it would go over 4, up 0. If this was 0, 0, it would go over 1, down 2. So the vector should be 5, negative 2. What the hell am I doing?
I don't know. Also, that's negative
Bro, that's 3. That's 3, not 2.
I
The answer is C, just circle it.
1, negative 2. So
No, it's
No,
3.
it's
Three.
negative
It's 3.
three.
Look at it.
3. So it's.
What is that?
I don't know. I'm having a stroke.
She did it.
Did it? Yeah!
Oh, it makes sense.
Last question.
Before you embarrass yourself anymore, just circle the
Last
answer.
question. Multiplying 3 by a vector just multiplies its components by 3. I do know this. Multiplying a negative by a vector just multiplies its components by a negative. And then if I add those together, I get 10, negative 6.
Yay!
Thank you. Good night.
That's a TED Talk.
That was embarrassing.
We're scaring me.
I'm cutting that part out of the video.